Type 3, if both functions are integrable separately and neither gives 0 on repeated differentiation, then it doesn't matter who we choose. Because, and this is a very typical exam question, and this is something you have to master, is no matter how many times I differentiate e to the power of x, I will still get e to the power of x. When I differentiate cosine x, I'm going to get negative sine x. And when I'm going to differentiate sine x, or rather negative sine x, I'm just going to get back a function that is within cosine x. So these two are functions that will keep on repeating itself no matter how many times you differentiate or integrate it. Yeah? And when you see exponential together with trigo, you must think of this technique called making the integral the subject. Okay, the subject. That means there's no way you can find the answer by getting it out itself. Okay, what do I mean? I will show you how. Okay, again, you can apply LIATE to this LIATE, and exponential comes at the last part, trigo comes before. So if you follow this strictly, then we are just going to choose cosine x as my u, my e power x as my v prime. Now let's write down our integration by parts formula. The integral of uv prime is equals to uv minus the integral of u prime v. Okay, this is the third time we are writing it today, or fourth time. I hope it gets into your head. So now let's do this proper. The integral of e power x cosine x dx. You can choose to do the table method like we did just now, or if not, you looking at the top, keep u cosine x, integrate v prime. I'm still just going to get e to the power of x. Minus the integral of u prime, differentiate cosine x, is negative sine x. Okay, and v is still e to the power of x dx. Okay, so I'm just going to get e power x cosine x plus the integral of e power x sine x dx. Oh, I look at him, it is still a product, so I'm going to choose he as my u, him as my v prime. I'm going to do by parts again, so pardon me, I'm just going to write the equal on the most left. This is equals to e power x cosine x. Whenever I do integration by parts twice, have a big bracket over here. uv, that would be sine x multiplied by e to the power of x. Minus the integral of u prime, differentiate sine. I'm going to get cosine x. Okay, and then integrate e power x. I'm still just going to get e power x dx. Okay, so I realize that, be careful, this is the equal sign, that the integral of e to the power of x cosine x, which is the question that I'm looking for, is equals to e to the power of x cos x, break up the bracket, plus e to the power of x sine x, minus the integral of e to the power of x cosine x dx. Do you realize that this and this, they are the same? So I can bring it over to the left side. I can bring both yellow highlighted expressions to the left side. I'm going to get 2 integral of e to the power of x cosine x dx equals to e power x cosine x plus e to the power of x sine x. So if 2 of the integral of this is equals to these two, final answer, all I can say is that the integral of e to the power of x, which is the question that you're looking for, is half of e power, even I should factorize out e to the power of x to make it nice. Cosine x plus sine x. And then let's have an arbitrary constant behind. Okay, and this is how we do integration by parts of e to the power of some x, cosine x. The x could change, it could be e to the power of 2x, which could make it more complicated, but it doesn't matter. Usually in this kind of case, we have to integrate it twice, apply integration by part twice, and we make the integral the subject.